The law of cosines solves any triangle, not just right triangles. And it looks a little bit like the Pythagorean theorem in that we start out with one of the sides, we add the two other sides and square them. But if that was true, it would possibly be a right triangle, and this is not necessarily a right triangle. So then we're going to subtract and multiply 2 times the other two sides. But here's the thing that helps us figure out which angle or which side we're solving for. If you notice, a squared, or a, is a side. Capital letter A is an angle. They're the side and the opposite angle. And this pattern is true for the other two values. You take the other two sides, square them, and add. Multiply their product by 2, and then multiply by the third angle. And I went ahead and filled in the third one for you. So we're going to solve some triangles using the law of cosines now. Okay, we're going to solve triangle ABC. I've given you two sides, A and B, and the angle that's in between them, angle C, and it looks something like this. So if this is side A, side B, side C, the angle opposite side C is angle C. So we know that this is 70. And so we need to find side C, we need to find angle A, and we need to find angle B. Well, we're going to start, actually let's just start with finding side C and forget these two for the moment. And we'll forget solving for the moment. So let's just start with finding side C. Well, our formula says that C squared is equal to A squared plus B squared minus 2AB times the cosine of angle C. So you see on each end, and we're going to substitute in. So we've got A squared is 100 because 10 squared, and then we have 169, and then 2 times A times B, which is 130, and then cosine of 70. Now we could substitute into your calculator and do cosine of 70 and find the 4 digits that we like to use, or you can just substitute the whole thing into your calculator. And once you add all that up, you're going to end up with about 180.08. And then you'll take the square root of this. And we're going to round to one decimal place, so 13.4. And this gives us side C. Now, we could put, now that we have all three sides, we could put it into the equation and then solve for angle A or angle B. So we could keep on going with that process, so we'll do that on the next problem. Well, rather than solve a triangle, we're going to call back up something from geometry, that the largest angle is across from the longest side. And we have side A, which is 30, and that means this is angle A. Side B is 20, angle B, and side C is 40, so angle C. Now what we remember from geometry is that the longest side is opposite the largest angle. So the largest angle is going to be angle C. So that means we're going to have C's on each end. So 40 squared equals 30 squared plus 20 squared minus 2 times those multiplied. So that would be 600 times cosine of C. Well, C is stuck inside the cosine, so we're going to have to solve for cosine C. Well, we have 1600, so 900 plus 400, that's 1300 minus 1200 cosine. Now the temptation is going to be to subtract 1,300 and 1,200, but you can't do that because 1,200 is multiplied times the cosine, so don't do that. So we're going to subtract 1,300 and get 300 is equal to negative 1,200 cosine C, and then divide both sides by 1,200, and that actually leaves us with a negative 1/4 is equal to cosine C. So we're going to inverse both sides, including the negative, and then when we solve for that and put that into your calculator, you end up with your angle being 104.5 degrees. And it makes sense because on the unit circle, cosine is negative in the second quadrant, and we put a negative value in, so that gave us a second quadrant answer.